Hello everyone, I am back with another video of Python interview hack by Python Academy. Today I am with the topic called queue. In this, I am going to focus on what is queue, operations of queue, and implementing the queue using Python. So let us see what is queue. So queue is an order group of some data type items of element. Then queue have two ends, that is I am explaining here structure wise. It has two ends. The elements are added at one end, the elements are removed from another end. The element added first is also removed first, that is, it is first in first out type data structure. Now with the pictorial I am going to explain. Suppose this is the entrance and from one end it is entering one by one, and once all the data has been added, then that queue will be termed as full queue. Then in same case as we have seen the first in first out. So when it is start removing, means when the data is start removing from the queue, the first element which has entered in a queue will be removed out first, like this. First, then this is second, then third, and so on. And once all data has been removed, then it will be termed as empty queue. Now let us see an example of queue. So the very general example is the general queue for the box office line. As everyone knows, for booking the ticket we have to be in a queue. That is the same example we are using here. Suppose these are the people and who are being in a queue one by one. So the first person will be termed as first in a queue, then second and third person will be termed as second in a queue, and similarly this is the third and this one is the fourth. So like this, in data structure also the elements are entered in a queue one by one. The first one, then back one, and again go on. Then similarly the first will be come out from the queue. So this is the example like a queue, that first in first out. So same thing is happening in our regular real life example also. Now let us see the queue operations. The various queue operations are enqueue, that is entering or adding the data in a queue. Then dequeue means removing data from the queue. Then there are two terms, that is empty and is full, means it is checking the condition that whether the queue is empty or whether it is full. Let us see how to implement the queue in Python. So as we have seen in the PPT that various operations of queue are enqueue operation, dequeue operation. Then if you want to check whether the queue is full, the operation is if full, and if we want to check whether the queue is empty, then the operation is empty. So for that purpose, the first important thing you guys have to understand is queue is open from both ends. So data can be inserted from left end as well as right end. So for that purpose I am going to use the method by using list data type. Means for getting the queue operation I am going to use the list data type in Python, and for that purpose I am going to use the method called append. So this method I am going to use for inserting the data from right end, means from right end data will be inserted and the queue will be created. Same way for left end I am going to use the operation or the method in list called list.insert. Okay. Then for dequeue operation, two methods I am using. To remove the data from left end I am going to use pop operation along with the index value, and to remove data from right end I am going to use only the pop method without index. Okay, when I will implement it on the while working on the queue, you will easily able to see that how the data is getting inserted and how we will get the queue effect from both ends, right as well as left. I am going to show both examples. So here what I have done, I have created certain functions. So this function I have created for left NQ. This separate function I have created for right NQ. So for left NQ I have used the method of list called name of the list dot append, and I am going to insert the element, and for that purpose I have passed the two position arguments, that is called queue list as well as element. So the queue list I have given the argument as whatever the list we are going to provide it for NQ operation. That list I have used as a position argument at the first position, and the element which we are going to insert inside the list is I have termed the argument as the element. Similarly, for right NQ operation I have used three position arguments, that is the list in which we want to apply queue operation, then the index number as well as element. Now why I have used index number? Because the list having a method which is called insert. As you know that for adding the elements in the list there are three methods. One is append, another is insert, and third one is extend. So for right queue, for right entrance, for inserting the data from the right end, I am going to use the insert method, and for application of insert method we have to mention the index number as well as the value of the element. So for that purpose I have used three positional arguments here. Then for DQ operation again I have made two functions here. One is left DQ and another is right DQ. For left DQ I am using pop function, because again in list, as you know, for removing the item from a particular location or from the end of the list we have the method called pop. If you want to remove the value or the element from a particular position, you have to use pop along with the index number. And if you want to remove from the end, the last position, then you have to use only the pop. There won't be any index number inside this parenthesis. Then for checking is full, means for checking whether the queue is full or not, this is the method I have created where I have applied if else condition here. Means according to this, if what I have done here, whatever is the size we have considered for the queue, I am going to compare that size with the current elements or the current size of the list. So that's why I have applied whatever is the current length of the queue. If it is greater than or equal to size, then it will indicate the queue is full, and if it is not, then what I have done here, I have subtracted the actual targeted queue size minus the length of the current queue. So it will show you that what may be the possible elements we can insert in a queue. Then similarly for checking whether the queue is empty or not, if the queue is empty, I have written if not queue. Not queue means technically it will be termed as if not true, then the queue will be treated as an empty queue, and else it will show you the queue is not empty. Okay, so by using these various functions we are going to apply the queue operation. So here I am going to show you. First of all, the left entrance queue. I have taken one list, a blank list. I have given the name it as a left queue, and for this purpose, as I have written here, that I am making the queue of 4 elements. So consider the targeted size of the queue is 4. So for adding the 4 elements in a queue, I am going to apply the for loop here. So I have taken the for add means this is the variable name in the range of 4, and this is the option I have provided to take the input from the user, and it will get append in this blank list. So for that purpose I have called the function left NQ operation. As you know, for inserting the data the operation is NQ, and I want to insert it from left end, so that's why I have in the previously, as I told you, I have made 4 various operations for NQ2 and for DQ2, as the queue has 2 ends, left and right. So as I have made a separate operation for left NQ, so this is the left queue function, and it has 2 positional arguments. So for that purpose I have provided the blank list, which is termed as left queue, and for element I have given the data 1. Now data 1 means in the data 1 I am going to take the user element, and this data is inserted here, so automatically it will be added inside the queue. So that's why I have given the print left queue. So let me run. Similarly, for removing, for DQ operation I have used for remove in a range, means remove is the variable name for the for loop, and I have implemented the left DQ function here. So let us see NQ and DQ from the left. Let me run this example. Let us check how we can apply the queue from left end. So here I am going to run it. It is asking me to enter the element, so I am entering element one by one, and for just example purpose I have considered the 4 element queue. So this I have entered 4, and as you can see, as it is left end, so data will be inserted from the left side, and here you can see left sided queue. So in the extreme left side the first element, then the second element, third and the fourth. As you can see here, first one I have inserted 23rd. So from at the left side you can see it is 23rd, then 56, then 89 and 29. Along with that I have removed 2 elements from here. So as you can see, it is the first in first out, so first 23 has been removed, then 56 has been removed, and the next remaining 2 is available. So final queue is 89 and 24. Apply for right ended queue. So for that purpose I have taken again a blank list which is termed as right queue. For that purpose again I have applied a for loop, but as the data is going to insert from the right side, so data will be the right sided queue. So for that purpose, as you know, the range has 3 parameters, that is the start of the range, end of the range and the step. So as it is the right sided queue, so I am going to start it from extremely right end. So according to its index number is -1, then it will be end up to -5. Why? Because I am going to make the queue of 4 elements. So as everyone knows that the end is always take n-1, means if I want to go for 4 elements to be inserted in a queue, then I have to take the end as -5. Okay, and as it will work from reverse side, means from right end it will be appended. So that's why I have taken the step as a -1. So here it will take the input from the user, and I have applied the right NQ function along with the position argument of right queue, that is the queue in which I want to insert, the list in which I want to insert. Then as it is the insert operation, we have to provide index as well as the value. So for index purpose j will be there, and whatever data I am going to take in a data 2, it will be appended here. So by passing these 3 positional arguments, we will get the flavor of right NQ operation. Similarly, I am going to remove the 2 elements from the right ended queue. So for that purpose I have applied right DQ operation here. So let us see how it will work. I'm going to insert again 4 elements. Now as you can see, 78 is the first element and it is at the extremely right end. Then after that 45, 12 and 25. Like this you can see, and afterwards I am going to remove, as I have removed 2 elements, you can see from the right end 78 and 45 has been removed. Then 12 and 25 is the available elements, and it is the queue size of 2 elements. Now let us check whether the current list is full or not. So I am going to apply it for the left queue. Okay, so I am going to apply for the left queue. I am running it. So it is what the facility I have made here, that I want to know that what will be the target size of the queue. Means if I want to if my size of the queue is 4, and if I and already if the 4 elements are there, then it will show me the queue is full, and if not, then it will show me how many elements I can insert there. So let us see. As of now, I want my aim targeted queue is suppose 6. It means I want to check whether for 6 element the queue is full or not. So I am going enter 6 here. So it will show me you can insert 4 elements. Why? Because as you know, for the left hand queue here we have already 2 elements, and I have given here the size for the 6. So I have the facility, or we have the space to insert 4 elements there. And if I run it again, and if I provide only for 2 size, then it will show you the queue is full. So this is for checking purpose. Similarly for empty also, it will show us whether the queue is empty or not. So as in this I have applied for the right queue, and as you knows here, for right queue there are 2 elements are there. It means the queue is not empty, so it is showing me the queue is not empty. So this was all about the queue operation implementing in the Python. Thank you very much.